All right. Well, once again, we want to welcome everybody to today's Vaughan Company webinar, Bypass the Competition, Avoiding Cleanups with Portable Pumps. In this session, we're going to discuss how having a reliable pumping solution in your fleet can help you avoid many costly and messy cleanups. Lots of great information here by our presenters. If you're new to our Vaughan webinar platform, we take all of our questions, almost all of them anyway, at the very end of the session, but you can type in your questions right there in that bottom screen. Those questions will come back to Jason and Tom and Stephanie and myself, and we'll answer those after we get through the PowerPoint, so we make sure that we get through all of the content. And Tom and Jason have a lot of great information in here. You guys are going to get a lot out of today's information and webinar. So with that, let me, I also remind you, if you want a participation certificate, that will be available. We'll have a link at the end of the webinar for you as well. Just be able to click that link, provide your information, and there will be a little pop-up that'll give you right away for you to download that. So, all right, let's go ahead and welcome in our two presenters. First of all, we want to welcome 5-year Vaughan Company team member, Jason Chase. Jason's experience includes over 13 years in various operations positions within chemical, pulp, and paper, as well as the fire industries. Jason, I think this is your first time on the Vaughan webinar platform. Welcome, sir.
It is first time. Glad to be here.
All right, and also a first-timer is Vaughan's Director of Business Development, Tom Thompson. Tom's been with the Vaughan Company for the past 9 years, and before making his way here, he spent time with Westport Shipyard, Simpson Door Company, as well as the Boeing Company. He has a bachelor's in science in civil engineering and a master's in engineering management. Tom, it's great to have you in the Vaughan webinar room as well. And with that, I think I'll hand it over to you and let you get started.
Okay, let's get started. And I just want to say welcome out to everybody, and we're glad you're able to join us. So with that said, we'll get started here. So just kind of in setting the stage here in terms of the situation, portable pumps play a key role and are necessary to complete your pump-related infrastructure. Everybody deals with pumps, but today we're going to really focus on just the portable units. Failures in the system can lead to environmental impacts that are costly to mitigate, so you all understand if you have a lift station or something that you're working on and the pump fails and the lift station backs up and overflows either onto a street or into a waterway, that's a bad situation. To mitigate failures, Vaughan's self-priming chopper pump packages deliver clog-free operations that can be ready to roll in support of routine equipment maintenance, system failures, high-flow emergency situations, and emergency standby operations. So what we're going to talk about and focus on today are system design considerations for portable bypass pumping. That's the section that I'm going to address, and there's just a lot of technical detail there. Jason's going to pick up the systems components and how Vaughan Chopper Pumps can improve bypass pumping. So I'm going to get started with considerations for portable bypass pumping system design. So the topics that we're going to cover today are a few. First of all, we're going to talk about centrifugal pump factoids, what you know and don't know. Calculating NPSHA, solving NPSHA problems, prime time, and typical portable pump priming issues, and EPA engine requirements. So just in general, or 30,000-foot perspective of NPSHA and priming, they're two different issues. We can prime a pump without actually flowing material through the pump, although in portable units, most often the pump priming system is driven off the pump shaft, which is driven by the engine. So just again, keep in mind those are two different issues. So the first section that we're going to deal with are just the factoids, things you may or may not know. So from a pump operation perspective, priming versus pumping, like I said, are two different animals. When you talk to people and they ask how a centrifugal pump might operate, you'll often hear the term that the pump sucks liquid into the pump. That's partially true, but in nature, fluid flows from high pressure to low pressure. And pumps operate by creating a low pressure at the eye of the impeller, which allows liquid to be pushed into the pump by atmospheric pressure. This occurs naturally when the material being pumped is above the entrance to the pump, but in many cases the liquid that you're pumping to the pump is below the pump level, so the material has to be lifted to the pump. This is done by creating a vacuum at the suction of the pump. So just imagine that we've all taken a glass of beverage and put a straw in it, and what we think we're sucking the material into your mouth or throat and then swallowing it. In reality, what you're doing is you're creating a low pressure in your mouth or throat. An atmosphere is pushing down on that liquid and pushing the material through the straw in your mouth. And the other thing to consider is with centrifugal pumps, the liquid has to be flowable. If you take a bucket of material that you're trying to pump and pour it out in the ground, it has to seek its own equilibrium or flow. So if that doesn't happen, it stays in the shape of the bucket, the material isn't flowable, and a centrifugal pump cannot pump it. The same thing if you're trying to take you go to the dairy and you have a very thick milkshake, and you try to draw that through a straw in your mouth, and oftentimes you'll just suck the straw flat. Well, that material really is too thick to flow through the straw or be pumped. So therefore, you're not going to get it into your mouth. It's just too thick. Even in a perfect vacuum at the pump inlet, atmospheric pressure is limited to how high the vacuum system can lift the liquid. These limits also affect the pump's performance, which is constrained by the net positive suction head. So in the next two, there's actually two parts to NPSH. One is the NPSH required, and this is the minimum pressure required at the suction port of the pump to keep the pump from cavitating. NPSHA available is the absolute pressure at the suction port of the pump. So NPSHA is a function of your system and must be calculated, whereas NPSHR is a function of the pump and must be provided by the pump manufacturer. So to get flow through the pump, NPSHA must be greater than NPSHR for the pump system to operate without cavitating. If that's not true, the pump will still operate, but you're going to have a very noisy pump, and as a result will cause damage to the pump. But another way, you must have more suction side pressure available than the pump requires. Okay, vapor pressure and cavitation. These kind of go hand in hand, but to understand cavitation, you first must understand vapor pressure. So vapor pressure is the pressure required to boil a liquid at a given temperature. Vapor pressure is often or also affected by the temperature of the liquid being pumped. So you can see at the chart to the right, you see various temperatures. Let's just pick 160 degrees, and that actually equates to 11 feet of vapor pressure. So that is a tremendous negative draw on trying to get material into your pump. So it's something that always must be considered along with elevation. So pump cavitation occurs when the pressure in the pump inlet drops below the vapor pressure of the liquid. When this occurs, vapor bubbles from the inlet of the pump are moved to the discharge side of the pump, where they collapse, often taking small pieces of the pump with them. So when you look at a casing or an impeller, you'll see pitting, and there's two causes of that pitting. It could be corrosion or it could be cavitation. Typically, when we feel the surface of the impeller or the casing, if it's sharp, has sharp edges, that's probably cavitation. That's where the metal is being ripped apart. And also, the higher the flow rate, the lower the pressure at the eye of the impeller. So liquid temperature has an even greater effect on cavitation. So characteristics of cavitation, and you've probably all heard this, you may hear a loud noise, often described as grinding, or it may sound like marbles inside the pump. You'll also feel vibration. The pump is not stable. So along with being noisy, it's going to be vibrating. Loss of capacity. Bubbles are now taking up the space where liquid should be. And pitting, which we talked about, pitting damage to parts as material is removed by the collapsing bubbles. Okay, so calculating NPSH. So we talked about there's two elements to NPSH. There's NPSHR and there's NPSHA. To calculate NPSHA, we have to know what the atmospheric pressures or head pressure. We have to know what elevation the liquid is, either above or below the pump, the friction loss that we have, the vapor pressure loss, and the velocity head loss. Oftentimes, the velocity head loss is negligible, so we don't consider that. But if you look at the curve, if I can turn the arrow on, there we go. You can see the point here where we have a red cross-hatching there. That is right at the 15 feet of NPSHR. So that comes from the pump curve. So we're going to try to operate this pump at 600 gallons a minute at 37 feet of total dynamic head. So again, every pump curve that is designed or built for a portable pump should have NPSHR lines on it that indicate where the net pressure suction head required is, depending on the flow and the head of the pump. We also suggest that we throw in a safety margin when we're doing this calculation, just because of the variables in the system. And then depending on the design of the pump, we recommend that the ratio of NPSHA to NPSHR be from 1.1 to 2.5. So these are some examples of some calculations that we did. You can see the pump design at the bottom where we have a pit we're pumping out of, and that's at about 16 feet, and then we're lifting about 10 feet above the pump. So that doesn't have anything to do with the suction side of the pump, but that's the example that we're showing. So NPSHA at sea level, using a 6-inch suction hose, we start out with the barometric pressure or head pressure of 34 feet, and then we have to start subtracting things from that to get to our NPSHA. So we have a lift of 16 feet, that's the H sub Z. Our friction loss is 0.7 feet. Our vapor pressure loss is 0.6 feet, and our margin of safety is 2 feet. So we end up with an NPSH of 14.7 feet, which is below the 15 feet. So this pump is going to cavitate, which is not what we want to see. So the next example is, again, the NPSHA at sea level. We're going to go to an 8-inch suction hose. So we still have the same atmospheric pressure. We're still at sea level. Our H sub Z is still 16 feet. But what has changed is the friction loss, and it went down to 0.2 feet. The vapor pressure is still the same. The safety margin is still the same. So running the numbers, we get an NPSHA of 15.2 feet, which is above the required NPSHR. And if we look at the ratio, we're at 1.01, which is not quite where we want to be, but we also have a 2 feet of safety margin, which is debatable. So we're close. So that pump is going to run. It's not going to cavitate. So let's just take the same scenario, and we're going to bump it up to 2,000 feet. So now our atmospheric pressure or head pressure available is only 31.6 feet. So we start running the numbers again, and we end up with only 12.8 feet of NPSHA, which is below that's required of the pump. So this pump is definitely going to cavitate. So this is a situation that we want to avoid. So if that is a situation that we have, we're going to have to make some remedies to keep the pump from cavitating. Okay, so solving problems of NPSHA. Obviously, the first step is to diagnose the pump problem. You're going to see possibly or hear noise. You're going to have capacity loss, and again, we talked about pitting are the major indicators. But direct measurement not only helps to confirm your suspicion, but it also helps you know your true NPSHA. So the simplest way to do that is just to install a compound gauge into the suction port of the pump, or as close as you can get to this in the suction piping itself. When the pump is running, the reading from this gauge will be equal to your NPSHA less vapor pressure. If after subtracting the vapor pressure, this value is less than the pump NPSHR, you'll have confirmed that this is your problem. You have a cavitational problem. So diagnosing the problem is the easy part. Fixing the problem is usually more difficult. So we take a step-by-step approach by looking at each of the NPSHA factors to help understand what the problem or where the problem may lie and make those corrections. Okay, so prime time. So again, we talked about NPSHA and R are things that affect the performance of the pump. Prime time is a separate issue. It's just things that affect how much time it takes to prime a pump. So first of all, we need to understand that there's different types of self-primers. We have a wet prime and we have a dry prime system. In most of our portable pumps, we supply a dry prime system, which is an added feature to the pump itself to allow us to remove air from the suction line to prime the pump. Excuse me, these pumps can prime indefinitely, whereas wet priming systems can prime about 5 minutes before the water in the priming chamber boils. Number two, priming systems work independent from the pump operation, which we just talked about. Number three, priming time is slowed as the suction hose diameter is increased. So again, as we increase the diameter, we're going to add volume of air to be removed, which takes more time. So we can see in the example below, when we go from 6 to 8 feet of suction hose size, the diameter obviously increases and the volume almost triples. So the time to prime goes from 6 to 18 seconds. And then you can see the friction loss, obviously, with a bigger hose diameter goes down. But again, that's a significant increase to prime time. So priming time is optimized when the suction line is vertical up to the center of the volute and the horizontal pipe run is minimized. So the rate of air evacuation is reduced as the straight line of horizontal piping is extended. And then priming time is further minimized when running the horizontal section of the suction pump halfway up the vertical run of the piping. And I was supposed to, there we go. So there's some, so you can see when we extend the horizontal run of pipe, that's going to extend the prime time because we've lifted liquid up to the horizontal run. Now we've got to remove that air over a long horizontal run, which takes much more time. And then if we have a Z type affair, we get to remove that air in the horizontal piping with much less lift involved. So that's a better configuration, but that's not always possible when we are using flex hose. That's more of a permanent installation scenario. Okay, so now we're going to move on to typical portable pump priming issues. So one of the things you'll hear is that the lift is too high. Again, in a perfect situation, theoretically, we start out at sea level of 34 feet, but there's a lot of other factors that come into play. So we want to limit the suction lift to a maximum of 25 feet. So to minimize the effects of fluid temperature, specific gravity, friction, system leakage, and pump inefficiencies and elevation above sea level. You'll hear many portable pump manufacturers advertise that they can prime up to 28 feet or 29 feet or 30 feet or whatever it may be. Those are all theoretical numbers. But in reality, when you're out in the field, there's all kinds of other things that affect the ability to lift. So we just say, let's be conservative and try not to set up the system where you're going to be over 25 feet. Site elevation is often not considered. Again, as we talked about, there's less head pressure the higher you go up in elevation. So for example, at 75-degree water, for every 1,000 feet of elevation gain, the barometric pressure is reduced approximately 1 foot. You'll also hear the pump is too far from the liquid source. And again, the longer that horizontal run of suction hose is, it takes that much longer to remove that air. So we usually like to say, let's not go any more than 25 to 30 feet. Prudent system design dictates that the suction pipe length be held to a minimum to promote long pump life. So when we talk about priming, we also talk about the reality of that is we're going to have leaks in the system. So if we have long suction hose lengths and we have to remove that air, if we have leaks in the system, you're going to be drawing air into the system, which is going to take much longer to prime, even if you can prime, and it's going to cause the pump to cavitate because you're going to be continuously introducing air into the system. One of the ways to check for a leak in the system is just take plastic wrap or cellophane and wrap around the flanges or fittings of suspected areas of leakage to block the airflow into the pump. So again, because that suction line is under vacuum, you're not going to see any material leaking out of the hose. It's going to be drawing air into the hose. Another thing that we have to consider is suction flow velocity. We have to make sure that's sufficient to be able to lift solids up to the pump. We recommend about 6 to 8 feet per second. Again, when we're using flexible pipe, normally has a reduced internal diameter, and this is, again, critical to remember when you're calculating your NPSHA. Normally, the flex pipe ID and adapters are smaller than the standard pipe. Think of the dimensions as tubing rather than pipe. Determination of the pipe friction for NPSH calculations, like I already mentioned, will be incorrect if the reduced ID is neglected. And then we want to also just check out the hose condition. Sometimes the older hose is brittle and may have a pipe liner that can collapse under suction or vacuum and block the line. And then also we talked about consider the pipe size and pump geometry. Most experienced pump users know that as a general rule, we should always try to upsize the suction line one size larger than the pump suction. Self-priming pumps are an exception, and the suction piping should be the same size as the pump suction. We don't mind this in fraction, and we encourage this because it lessens the volume of air that has to be removed. More air means more prime time. So again, we see the volume and time to pump or prime a pump in the chart below. So again, we go from 6-inch at 6 minutes or 6 seconds to a 10-inch diameter goes to almost 18 seconds. And then the added friction loss from using the smaller size pipe is just another reason to eliminate. Oftentimes there'll be a foot valve or a suction strainer. Now the thing when we use a chopper pump, we don't need to worry about plugging the pump up, so we don't need a strainer. Sometimes we may need a rock trap if we're pumping rocks because we don't want to suck rocks up into the pump and damage the impeller or cutter bar. Never install piping that is smaller than the pump suction on any pump. Another thing that will occur in the field is when we're laying out our suction pipe, there'll be something in front of the pump. There'll be an obstruction, so we'll run the pump up higher over the obstruction and down to the pump. That causes a high point in the piping and can be a place for air and other non-condensable gases to collect, which will cause the pump to bind. So again, something to be avoided. So in review, what we want to do is pump directly, the hose run directly out of the pit and right into the pump. Okay, another thing to consider is watch the submergence of the suction hose. So we'll dump a suction hose down into a pit, and typically there's going to be floats. It could be just a high-low level float. And we need to make sure those floats are adjusted so we maintain that submergence. If the surface becomes too close to the suction of the pipe, we create a vortex, which is a path for air to be drawn into the pump. And again, that's going to cause vibration, and that causes problems with the pump itself in terms of wear. Because of the vibration that occurs, the pump impeller, mechanical seals, bearings, as well as piping and couplings can be damaged by the vortex condition. Another thing to remember, and you'll see on our pumps, is we have a seal oil reservoir that supplies an ample supply of oil to the seal. So during priming operations, you have a low pressure in the volute of the pump, which is going to draw oil out of the seal oil reservoir and into the casing. So we need to make sure we have an ample supply of oil. So as that oil is drawn out of the or across the seal faces out of the seal chamber, that we don't run the pump dry of oil. So because of this oil, the pump can run dry, and it doesn't hurt the pump at all, but we need to have a sufficient supply of oil. Okay, lastly, when we talk about engines, as you probably all know, there's EPA regulations that control the type of engine that we have available to us. So back in the 90s, we had what was called a Tier 1 style engine, and the emissions were really not controlled or regulated. As we moved through time, we went through a various tier level, and now we're to Tier 4 final, which you can see is really minimizes the gases and the particular particles that can be released into the atmosphere. So this is true unless we have a pump that's being used in an emergency situation. So if we have a standby pump, it's only used as a backup or for emergency if we lose power or there's a high flow situation, we can use a Tier 3 or interim Tier 4 engine. So just be aware of that. If that's the case, you need to let us know that, and then we can specify that engine, which is going to be much less expensive than the Tier 4 final. So there's a couple slides here that talk about that. I'm not going to go over that in detail, but those are there for you if you want to investigate that further. So that concludes my portion of the presentation. And so I'm going to turn this over to Jason, and he's going to go through the next set of slides.
Hey, thanks, Tom. We're going to jump into the Vaughan dry pipe package and its system components, and kind of let you guys know what's available and how our pumps are configured. On the first slide, we have our options that are available in the trailer or portable units. As you can see there, we offer enclosed trailer and skid units, open trailer and skid units, and in that bottom picture, we do pump and priming system packages. If you have existing trailers you'd like to retrofit, or even manufacture, build your own trailers on site. This is important for a lot of people, the pump and priming system package for overseas. That alleviates a lot of shipping issues with exporting. So here's kind of a breakdown of the components that are included in our packages. You start with the trailer frame. The trailer frame has an HDPE tank mounted inside of the trailer frame itself, with a controller mounted to the lifting lug and bale. Here's our diesel engine with the pump mounted and priming system, which is fabbed onto the trailer itself. Then depending on if it's an open or enclosed unit, here's the enclosure. All those meet all of the decibel ratings that are required for the enclosed units. And the next segment is the options. Here we just threw on the roof rack. That's one of our more popular options, is the roof mounted hose rack. So next, here's some of the portable pump features. As we touch on a few, sound attenuated. We have a lot of options available for these portable pump units, so don't be afraid to ask if you're getting close to inquiring on our products. There's tons of options available. As Tom touched on, that second picture top left is the external oil level monitor. This allows easy visual sight of the seal oil levels and lets you know whether you need to add oil to that or not. Touched on the hose roof rack. Depending on the engine configurations and the models, priming systems, we have vacuum pumps and compressor prime systems available. Like I said, some engine manufacturers require one or the other. And it's up to the end user and their specs on which they prefer. Vacuum pumps do prime faster than compressors on average. Interior lights, exterior lights are all options, very popular options. So in our portable pump units, we have sizes 3 through 16 inch on our chopper pumps. We're kind of going to break down the pump and talk about what differentiates the Vaughan Chopper Pump than traditional non-clog pumps. So here's kind of the casing removed from our wet end. Talk about the different components. So our pumps on these trailers are back pull-out casings. So they are adjustable. If you look at the external adjusters as the life cycle of this pump and the pump wears, you can actually close that tolerance between the impeller and cutter bar to increase the life cycle of the pump and components themselves to ensure proper chopping. Now there's an external adjusters all the way around the back plate that allow you to do so. We have an impeller, cutter bar, and cutter nut, which are all important cutting features of our pumps. We'll go on next. So here's our back plate. As you can see, we have an external, or I should say insert cutter on the back plate that works in conjunction with the pump out vanes on the back of the impeller, and also the upper cutter, which works with the back pump out vanes on the back of the impeller as well. Those allow to keep any fibrous materials from wrapping around behind the impeller themselves or binding in front of the shaft. Here's the example of the pump out vanes. You can actually see the notches in the spiral pump out vanes that work in conjunction with the insert cutter, and you can actually see the stepped notches that work with the inside of the upper cutter as well. On the back of the cutter bar, there's actually a machined cutter that prevents any fibrous materials from wrapping around the leading edges of the impeller. It helps to ensure nothing clogs into the front of the impeller. These pumps are all included and come with the Vaughan Flushless mechanical seal. These are cartridge type oil-filled seals. These are all spec'd with tungsten carbide seal faces. It eliminates the stuffing box and cavities behind the impeller, and the pump out vanes ensure maximum flushing on the seal itself. They're easily maintained, easily to install, and these do incorporate that external seal oil reservoir so that you have that visual level indication so you know when you need to refill oil. Here's kind of a layout of the portable pump vacuum assist priming. You follow that yellow line there. You can kind of trace their airflow through the priming system itself. So in a typical priming operation, the pump loses prime, or you start the pump on an empty case. The float ball will drop, and it'll actually open the valve in the priming chamber. This allows the vacuum pump to pull the air through the priming chamber in the suction spool through the pump to work on vacating the air. The atmospheric pressure actually pushes the water from your source back into the pump. And as soon as the water level rises within the suction spool in their priming chamber, it pushes on your float ball, which closes your valve, and away you go. You have a good prime suction. Some of the advantage of the vacuum pump, as I said earlier, the vacuum pump moves more air, on average about 50 cubic feet per minute. Compressors vary. 13 is probably a good average number for most of the compressors, so they're a little bit slower priming. It's all automatic. There's no valves. Nothing to worry about on initial filling. You turn the pump on and it'll work on getting a prime. There's no carryover. There's no spillage. That's why it's considered a dry prime system. As soon as the pump has fluid coming into the wet end, the valve in the priming chamber closes and prevents any contaminants from coming into the vacuum pump itself and discharging. There's a little important note on the other side. There is a check valve on the discharge side as well to prevent trying to pull a suction or a vacuum on the discharge line as well. So we're just focusing on the suction side only. So the pumps are available with messenger systems, telemetry, and various monitoring. The LOFA CP750 controller that the pump's equipped with has a messenger kit and RemoteIQ available. This is kind of an outline of the components with the messenger system that is required for the full telemetry and monitoring system. With this, you can also subscribe to RemoteIQ, which is a cloud-based and cellular-based system that gives you full remote capability to operate the units. The CP750 controller does have the capabilities of being hardwired as well, either through Ethernet or a Modbus connection. If you're in a treatment plant or next to a lift station with an existing PLC you'd like to plug it right into and monitor it, that is an option. Depending on the type of pump, whether it's open or enclosed, they both still have a 6-pin float connector and an M12 transducer plug. In that center bottom picture, you can see those 2 connections. Those are actually on the back of an enclosed trailer, and on an open unit, they're actually located right between the control panel, both for easy use. Here's kind of a layout of the CP750 controllers that these trailers are equipped with. They're designed specifically for pumping applications. They work with all engine tiers, electronically or mechanically governed engines. If you want full remote capabilities on a mechanically actuated engine, or you would need your governed engine, you'll need the actual LOFA controller as well to help with that. The enclosure, the CP750s come in an aluminum enclosure. With the open units, they do come with a locking cover as well to keep anybody out of the control panel. The automatic start and stop functionalities combined with the throttle ramp up time and engine speed limits the CAN Plus as an ideal auto start control system. These panels can be configured any way, shape, or form you'd like. All of the interfaces, the graphs, charts, anything you'd like to monitor, that's 100% customizable to your needs. The auto throttling feature optimizes the engine speed to meet the demand for the transducer. So these pumps can ramp up and down based on wet well levels, fuel consumption, noise, however you have it programmed into the system. Here's the messenger module. This actually allows you to monitor the engine data, whether it's the ECU, you can fault codes, fuel levels, you can monitor all the pump panel data, and well as the GPS tracking for the units. This does allow the remote start and stop capabilities, data logging, reporting, all the notifications or alerts you have set as well, with conjunction with the RemoteIQ. Here's kind of the front end of the panel when it's running. These are different conditions on how the pumps can operate. There's a wide variety of how you want the pump to operate in what's available in this panel. You can operate on strictly water level from transducers, high and low or low level alarms, discharge water pressure if you're using a pressure transducer, or even flow on the discharge side. Pump float switches in the wet well, high and low floats, multiple floats. There is inputs as well you can monitor. They have, for examples, they have pump dilute temp or low vacuum, pump oil, or any other auxiliary inputs. Fuel level, you can have an alarm or monitor fuel levels, low fuel level alarms. Customizable percentages to send an alert saying that you need more oil or more fuel in this case. Engine status, whether it's running, not running, pump started, pump stopped, those are all alerts. Auto start's enabled, which meaning you're running it in an auto start based on levels. You can get alerts on all of that via text message, computers. Service timers, those are all service timers are all configured too, based on the customer's needs. So whether or not it be change oil, service pump, check seal oil level, that's all programmable into the controller. Here's kind of a flow chart on how the data moves within the messenger and RemoteIQ tracking service. So we have our pump with the CP750 and the messenger module, which goes up to the RemoteIQ cloud. Then from here it can be sent to either desktop users or it gets sent through the RemoteIQ servers to the different users set up on the thing, whether it's cell phones, laptops, people that are in the field can get alerts as well. And you can set up as many alerts as you want based on your needs. So here's kind of the desktop application. As you can see behind here, it actually shows a map of the United States. It'll be different depending on where you're at. Here we have our demo trailer, which you can see up here in Washington. So the units themselves, depending on how many assets you have hooked up to the program itself, will show up as little pin dots on the map. You click specifically on the pin dot, which it says this is our Vaughan demo trailer, and you can pull up and look at all the current stats on that trailer itself. And then it gives you indication as well whether it's in auto start mode or if there's any warning or shutdown initial warning lights. The biggest thing for this is if it shows if it is in auto start mode, that means it's set up in operation, and the auto start mode has to be enabled on the controller to give you the remote capabilities to monitor the unit. So then we click on that. Let me go back one here real quick. If you click on the engine control button here on the bottom, that takes you to the next screen. That takes you straight into that unit itself. That gives you the start and stop buttons. You can mimic the control panel. You can speed it up, slow it down. If there's any engine codes, fault codes, you can pull up all your timers. All the stuff that you have configured into that unit itself, you can look at or see the parameters and set points and where it's operating at currently. So here, how does the Vaughan Chopper Pumps improve bypass pumping operations in the new area of waste? There's a few testimonials from customers that have these currently in their fleets. One on the left's a bypass operation. There's a lot of rental companies out there that have incorporated the Vaughan Chopper Pumps into their units itself. This is a bypass job in Indiana where they have a dual bypass pump set up with 6-inch chopper pumps. No issues with pumps plugging. That handled all the debris in the lift station. The one on the right is actually from a customer in Florida. They were bypassing 2 lift stations right on a river dumping into the Gulf of Mexico. This was for a complete station rehab. They did 2 lift stations simultaneously and were able to bypass. And they had no issues with pumps plugging or anything. So what is new sewage? We kind of touched on this before on some of our previous webinars, but it's flushable wipes, any non-spherical solids, are the thing that are having everybody having nightmares about. Flushable wipes, baby wipes, cleansing wipes, disinfectant wipes, mop heads, rags, diapers. Anybody in the municipal wastewater field is well aware of the issues that everybody's having today. Here's a couple of examples of results of flushable wipes. Social media campaigns, there's a lot of people now, municipalities, cities, local governments, pushing big ad campaigns against flushable wipes. So this is not a new problem, but it's a ongoing problem that I don't believe there's an end in sight. So having a Vaughan Chopper Pump, portable pump in your fleet may be a good solution to help you combat these issues. What's the cost of health and safety? I mean, is there a cost too steep when you're having emergency bypasses, plugging pumps, you're having to send people in confined spaces? There's a lot of unnecessary exposure that goes down and is associated with any lift station or pumping issues. That pretty much wraps up that.
All right, Jason. Thank you. Great stuff, Tom. Jason, fantastic. Hey, before we get into more questions, and we do have some questions in here, Jason was just talking about flushable wipes. Raise your hand if you guys are having problems with flushable wipes. Let's see if that's something that you guys are dealing with. Up in the top of the screen, there's a little raise hand area. And love to see it. Yeah. See, Jason, Tom, I know no surprise here. We've got some folks that are having some challenges with it. So certainly that's something that's being dealt with out there. So. All right, drop your questions in the Q&A pod down there in the bottom area. Tom and Jason are here, and Tom went through some great content. And again, gentlemen, lots of great information here, very detailed with Tom's content. So definitely now's the time. We've got him on the line to bring your questions to both of these gentlemen. And Stephanie, I think I'll hand it off to you to get us started.
All right, thank you. Thank you, guys. Great presentation. All right, so now for some of the questions that the listeners had. First question, do bends in the flex pipe affect TDH?
I'll take a stab at that. So as long as it's a large radius bend, it's not going to have any effect on TDH. There's no friction loss penalty. If there's a kink, yeah, that will slow the flow. It'll cause more friction in the pipe. But generally, if we have a nice large radius, it has no penalty on friction loss or TDH.
Okay, thanks, Tom. Next question. Is it a recommendation to wrap joints on the flex pipe with shrink wrap on long distances? What is a good length in doing this?
The only time we'd use shrink wrap is if we suspect there's leaks in the joints. So if it's a new pipe or the piping has been taken care of, it's not deteriorated, and everything is priming properly and flowing properly, I don't hear any cavitation in the system, then I wouldn't worry about it. But if I suspect I'm having a leakage, a problem, either in the hose itself or in a joint, then I would try to wrap the joint or the pipe where I think there's a leak with some type of plastic wrap to see if that makes a difference. If it does make a difference and I then am able to locate that leak, then I would repair it. But I wouldn't use it as a fix, a long-term fix. It's only a solution or a suggestion to help isolate any leak that you may have.
Okay, next question. Are these panels CSA approved?
Yes, they are. Everybody hearing me okay?
Yeah, we're doing good, Tom. You're good.
Yep, all right. Next question. Thanks, Tom. Next question is, can a Triton screw pump be mounted to the trailer?
Go ahead, Jason.
Yep. Yes, we can use Triton screw pumps on these trailers as well, whether it's skids or trailer mounted units.
Okay, last question that I've got here is, can we get a copy of this presentation? And yes, absolutely, these will be available. Give us about 48 hours to make that available to you guys. This will be available on the Vaughan education page at www.chopperpumps.com/education. And anybody out there that also would like a copy of just the PowerPoint presentation that was on here today, you may send an email to info@chopperpumps, pumps is plural, info@chopperpumps.com with your request.
Thanks, Stephanie. Well, let's do a quick reminder and talk about also what's on the screen here. So if you guys have any last questions for Tom or Jason or Stephanie and team, just type them right in that Q&A pod right below the PowerPoint presentation. Let's talk real quick on what's on the screen here. We've already got a few folks that have provided topics that you'd be interested in for future webinars. Always want to do that because, as Stephanie talked out at the beginning, we are working on our fall webinar series. We've got a great bypass trailer video out on the website, so you can click there in that screen. That'll take you to that video, and then the portable pump inquiry form. That's a tool, really good information, gets some information, collects it before you come back to us, and then that just helps answer some questions. And in the other resources area, we've got links to the video page, the home page. Stephanie mentioned the education area, the bypass trailer web page in here, and then also if you want a participation certificate, click the participant certificate and then browse to. That will open up a new window for you, and you just provide your information and you'll get a certificate right there on the spot. So if you're watching this as a recorded session and none of the boxes are working because you're watching it as a video and you have questions, email us at info@chopperpumps.com, and that is where you've got Fernando's question as well. That's the email address for if you want a copy of the presentation or if you have any other questions that we might not capture today. So, all right, Stephanie, any last questions before we close out for the day?
No, it looks good. And if you guys, like I said and Scott said, if you, we close out of this webinar and you think, oh shoot, I didn't ask, I've got this question now. Go ahead and email your questions to info@chopperpumps.com, and we're more than happy to reach out and respond to any additional questions, comments you guys have at the close of this.
All right. Thank you, Stephanie. Jason, any last words before we close out for the day?
Nope, I think I'm good. That was a great presentation. Thanks for having me.
You bet. Thanks, Jason. Tom, any last words from your side?
I think we're good to go. We just encourage anybody out there that has any questions, like was mentioned earlier, to reach out to us. Both Jason and I are here to answer any questions. Just give us a call, and we'll address any questions you have, or can talk in more detail about some of the applications that may be applicable, or some of the different product configurations we have. Again, just to reiterate, we do have the pump priming system available now that can be shipped around the world. So there's a lot of people out there that maybe not want to buy the whole unit, meaning the trailer or skid, etc., but they just want the pump with priming system. That does come with a vacuum pump only. The vacuum pump does not need any hookups to the engine for oil or water, so it's a standalone system. And again, oftentimes engines come with compressors on them, so again, that's a non-issue as well. Those lines could be hooked right up to the pump itself. So that's about all I have. Again, thank you for all those who joined us, and again, if you have any questions, reach out to us whenever it's convenient for you.
All right. With that, thank you, Tom, Jason, Stephanie, and everybody for joining us today. Great content, great session. You can always visit us at chopperpumps.com for more information and other webinars recorded or coming up. And with that, we'll close down. So thanks, everybody, once again, and we will see you next time.